So the main focus of my research is focused on looking at the sun and when and how these large explosions happen in the atmosphere of the sun. Now, that might sound dramatic, but it's extremely important. Regularly and often, the sun releases a huge amount of magnetic energy, and this accelerates particles to extreme speeds and emits radiation across the entire electromagnetic spectrum. So much so that it actually can impact us here on Earth. It can impact our telecommunication systems, our satellites, and even power grids in extreme events. But also from that practical aspect from space weather of these drivers of these large events, it also is fundamental research that we have this natural laboratory in the sky where we can understand some of the most extreme conditions of plasma physics and astrophysics in a nearby close laboratory. So specifically what my research focuses on is these explosions which are called solar flares. And basically if you think of the complex magnetic field of the sun getting wound up like an elastic band, and every so often this elastic band can get so wound up that it explodes out magnetic energy. And this is what accelerates those charged particles, which are really important. So my research really focuses on understanding how that energy is converted into accelerating those particles to extreme speeds. And this is a really big question, not only in solar physics, but in astrophysics in general. And so to understand and to do this research, I use observations from different satellites in space and different ground-based observatories. Specifically at the moment, I'm working with the European Space Agency's Solar Orbiter mission, which is a mission that is doing two unique things. It's going extremely close to the sun, so we're getting the closest images we've ever seen of the sun, and also from a completely different viewpoint that we have from Earth. So for the first time ever, we've been able to get a different viewpoint and high-resolution observations of the sun. And using X-ray observations, which is a wavelength which is really excellent at diagnosing those accelerated particles, try to understand some of those fundamental questions about understanding how the sun is releasing this energy, how we live in this place beside a very active star, and what that means for the future for predicting these solar storms, and how can we better forecast them and mitigate their effects here on Earth. So the value or impact of my work has kind of two main threads. The first one is it is fundamental blue skies research, right? The sun offers us a natural laboratory in the sky where we can observe extreme astrophysical and plasma conditions, which we have no other opportunity to do so. So we have many missions looking at the sun and extreme details. We're talking about 100-kilometer pixel scales of being able to see details on the sun, to understand fundamental questions about how is magnetic energy released to accelerate charged particles. And that's, of course, is important not just for understanding what drives our own sun, it's important for driving, other astrophysical plasmas that we see throughout all aspects of the solar system, but also in conditions on Earth for fusion plasma reactors. For energy, this is something that we can mimic by looking at the sun. We can understand the same physics that is going on. So what my research is doing by using Solar Orbiter is trying to understand particle acceleration from a fundamental point of view. The other practical aspect of things, we live in proximity to a very active star, and we're now living in a society that's more and more susceptible to what the star is doing and how that impacts our technological infrastructure that we are more and more reliant on. So we have more and more satellites going into space. That's a huge economical impact to understand what are the conditions they are flying in and what impact does the sun have on those. So my research in understanding particle acceleration and flares, when and how they occur, are really important for understanding building better forecasting models. When are they going to occur? What is their impact? What is their directionality? How is it going to impact our technologies? And this is really, really important from that practical aspect as well. So the Royal Society Research Ireland University Research Fellowship has really been transformative, not only for this specific research, but also for my career. It's allowed me to come back to Ireland and establish a research programme here, doing cutting-edge research and placing Ireland, at the centre of that. Its longer-term funding of 8 years has really been key to not only thinking about what the next year is happening or the year after that, but thinking long-term ahead of what is driving this field forward and where is Ireland's place in that. And I think that has been fantastic to be able to really think ahead and think bigger picture, bigger questions, and really making new scientific discoveries.